So a few thoughts on this task and how you might want to use it. Now the first thing I'll mention is that you don't necessarily show the pupils all of this task to begin with. It's more of a teacher cheat sheet. What you do show them is the prompt at the bottom saying how many factors does 2520 have. Now that can be any number. I've just chosen 2520 because it's quite a special number, and I'll let you try and play around with it and see why. So the first thing we need to do is the prime factor decomposition, so that's one of the prerequisites for this. Now I'm not a fan of the prime factor tree because I think it looks a little bit messy, to be honest. So I much prefer to do my prime factor decomposition in a table like so. So we can see it's obviously divisible by 10, so let's take a 2 and a 5 out. So that gives us 252 left. And then let's divide it by 2, so that's going to be 126. And then let's divide it by 2 again. That's going to be, 63. And now we're into the 3 times table, so that's going to be 3 times 21. And then finally we've got 3 times 7 to finish, and then we're done. So the prime factorization here is these numbers here. So let's just build those out of prime factor tiles. We've got 2, 2, a 2. We've got a 3 and a 3, a 5 and a 7. So how can we use this prime factorization then to find all the factors of 2520? Well, the first thing you need to make pupils comfortable with is the fact that you can take any random selection of factors out, and you know that this will be a factor of the number. So here we've got 21 times 2, 42. So 42 is a factor of 2520. It's 42 multiplied by what's left, and what's left in this case is 60. 42 times 60 is 2520. And any random selection of prime factors will give you a factor of the 2520. So how can we count them all though? Because there seems like lots of possibilities. Well, here we can employ the product rule for counting, because essentially we want to know, okay, in this factor that I'm pulling out, how many 2's does it have in it? How many 3's does it have in? How many 5's and how many 7's? Now, because the prime factorization contains 3 2's, we can have a maximum of 3 2's and a minimum of 0 2's, which is 4 combinations. So 1, 2, 3 or 0. We've got 4 combinations there. How many 3's could we choose? Well, we could either choose 0, 1 or 2. So that's 3 combinations. How many 5's do we have in our factor? Well, we either have 1 5 or no 5's. So that's 2 combinations. And same with the 7's. We can either have 1 7 or 0 7's. And by the product rule for counting, if we multiply all these together, that will tell us how many factors there are of 2520. So 4 times 3, 12, times 2 again, 24, times 2 again is 48 different factors of 2520. And you can generalize this result by just looking at the indices or the index of the prime factorization. So if you look at the prime factorization, which we've got as 2 to the power 3, 3 to the power 2, times 5 and times 7. If you just put a 1 there and a 1 there for this example, you can see that essentially these numbers here, the 4, the 3, the 2 and the 2, are always 1 more than the index in the prime factorization. So that's a quick way to find how many factors a number has. Find its prime factorization, add 1 to each of the indexes of the distinct primes, and just multiply them all together. So hope you've enjoyed that, and as always, put any thoughts in the thread below.